Picture this: your fingertips brushing against a slab of rock, its surface etched with patterns that whisper of a world long vanished. These aren't just lines in stone, they're pages from Earth's diary, written over millions of years. And sometimes, when scientists turn those pages, they stumble upon mysteries so profound, they force us to rewrite everything we thought we knew about our planet. That's the power of geology. It's not just about rocks and dirt. It's about decoding the epic saga of Earth itself, a story filled with twists, catastrophes, and revelations that still leave experts in awe. Take the Grand Canyon, for example. At first glance, it's a breathtaking landscape carved by water and time. But look closer, and you'll find layers that defy expectation: boulders perched where they shouldn't be, gaps in the timeline that span millions of years, even evidence of ancient oceans that once stretched across continents. These aren't just quirks of nature, they're clues to a past far more dynamic and unpredictable than we ever imagined. And the Grand Canyon is just one piece of the puzzle. From the towering cliffs of Patagonia to the volcanic plains of Iceland, our planet hides geological enigmas that have overturned centuries of scientific thought, proving that Earth's history is anything but straightforward. That's exactly what we're diving into today: 30 geological mysteries that didn't just challenge scientists, but reshaped our very understanding of the planet. Some of these discoveries started with a single odd rock or a strange ripple in the Earth, leading to revelations that changed textbooks forever. Others were born from cataclysmic events: asteroid impacts, supervolcanoes, continents colliding, events so colossal, their fingerprints are still visible today. This isn't just a history lesson, it's a detective story, one where every clue brings us closer to answering the biggest question of all: how did Earth become the world we know? So let's begin this journey through deep time, where every layer has a story, and every mystery holds the key to something extraordinary. Some mysteries hide in plain sight, like the boulders of Death Valley that seem to dance across the desert when no one's watching. Picture a vast, cracked lakebed called Racetrack Playa, where rocks as heavy as 600 pounds suddenly scoot across the ground, carving eerie trails behind them. For years, these sailing stones baffled scientists. How could something so heavy move on its own, leaving tracks so precise they looked almost deliberate? Theories ranged from dust devils to magnetic fields, even playful ghosts. But the truth, when it finally came, was far more delicate and brilliant. Researchers armed with time-lapse cameras and tiny GPS units staked out the playa, enduring freezing nights and scorching days. Then, in 2013, they caught the stones in the act. Thin sheets of ice, fragile as window panes, formed overnight when rare rains pooled on the lakebed. By morning, sunlight melted the ice just enough to fracture it into massive floating panels. A light breeze, barely strong enough to flutter a flag, pushed these ice rafts across the mud, carrying the rocks with them like passengers on an invisible sled. The stones inched forward, their paths scribbled into the earth by the whims of wind and temperature. This wasn't just a quirky desert spectacle. It rewrote the rules of how we understand movement in nature. Before, no one imagined something as fleeting as a half-inch of ice could drag boulders across a landscape. But Death Valley proved that even the tiniest forces, given the right conditions, can leave monumental marks. It's a reminder that Earth's secrets aren't always hidden in grand catastrophes. Sometimes they're tucked into the quietest, most patient moments, waiting for us to look closer. And if rocks can glide across a desert, what other impossible things might just be a matter of perfect timing? The ocean has always been a place of mystery, but few spots spark as much intrigue as the Bermuda Triangle. Ships vanishing without distress calls, planes disappearing from radar for decades. These stories fueled wild theories about alien abductions or lost civilizations. But beneath the waves, geologists uncovered a far more plausible, yet equally dramatic explanation. The ocean floor here is a ticking time bomb of frozen gas. Hidden beneath layers of sediment lie vast deposits of methane hydrate, a crystalline form of natural gas trapped in ice. Under pressure, these deposits stay stable, but let that pressure drop, say, from a landslide or shifting tectonic plates, and the ice cages shatter, releasing torrents of methane bubbles. When that happens, the water transforms into a frothy, less dense fluid, like a freshly poured soda losing its fizz. For ships, this is catastrophic. Just as a stone sinks in water but floats in quicksand, vessels suddenly find themselves plunging through water that can no longer support their weight. Even modern ships engineered for rough seas stand little chance when the ocean itself turns against them. This discovery didn't just solve a maritime riddle, it rewrote our understanding of underwater hazards. Researchers now track similar methane vents from the North Sea to the coasts of Japan, where blowouts have left craters half a mile wide. The Bermuda Triangle taught us that Earth's most dangerous forces aren't always visible. Sometimes they're silent, waiting in the deep, reminding us that geology doesn't just shape land. It commands the seas too, and if bubbles can swallow ships, what other invisible threats might be lurking beneath the waves? The Grand Canyon seems like an open book of Earth's history, layer upon layer of rock telling a story that spans nearly 2 billion years. But flip to certain pages and you'll find something startling, a blank space. Not just any gap, but a colossal one where over 1 billion years of geological records simply vanish. This is the Great Unconformity, and it's one of the most puzzling mysteries in all of geology. Walk along the canyon's bright Angel Trail, and you can literally place one hand on ancient Precambrian rocks, some of the oldest on the planet, twisted and dark from eons of heat and pressure. Lift your other hand just a few feet higher, and suddenly you're touching smooth, horizontal layers of sandstone, limestone, and shale, deposited hundreds of millions of years later. Between them, nothing. No gradual transition, no intermediate layers, just an abrupt line where time itself seems to have been erased. What could have scraped away such an unimaginable stretch of Earth's story? One leading theory points to Snowball Earth, a period when glaciers may have encased the entire planet in ice. As these ice sheets crept across continents, they could have acted like planetary sandpaper, grinding away entire mountain ranges and leaving behind a barren, scarred surface. Others argue the gap was carved by tectonic violence, supercontinents ripping apart, thrusting ancient rock upward, only to be weathered into nothingness by wind and rain over millions of years. But here's what makes this mystery so profound. The Great Unconformity isn't unique to the Grand Canyon. Similar gaps appear on nearly every continent, hinting at a global event or series of events so dramatic it reset the geological record in places as far apart as Scotland and Australia. Whatever happened, it didn't just erase rock, it reshaped our understanding of how Earth's surface evolves. We used to think erosion was slow and steady, like a gentle rain wearing down stone. The Great Unconformity forced us to confront a far more turbulent truth, that our planet's history is written not just in layers, but in missing chapters, torn out by forces we're only beginning to comprehend. Perhaps the most haunting question isn't just what happened, but what stories were lost. 1 billion years is longer than complex life has existed on Earth. Whatever landscapes, climates, or even early life forms existed in that missing time, their traces are gone, leaving us with a cliffhanger written in stone. And that's the power of geology. It doesn't just reveal Earth's secrets, it reminds us how much we still don't know. In the frozen wasteland of Antarctica, where temperatures plunge so low that even bacteria struggle to survive, there's a glacier that bleeds. The Taylor Glacier, part of the McMurdo Dry Valleys, is home to one of the most surreal sights on Earth, a 5-story waterfall the color of rust, cascading down icy cliffs like a wound in the landscape. When explorers first stumbled upon Blood Falls in 1911, they assumed the crimson hue came from red algae, but the truth was far stranger and far more significant. Locked beneath the glacier for over 2 million years lies an ancient pocket of seawater, isolated from the rest of the planet since the time when early humans were just beginning to walk upright. As the glacier shifted, it squeezed this buried brine upward, forcing it through cracks in the ice. When the iron-rich liquid met the air, it oxidized instantly, turning the water the color of dried blood. But the real shock came when scientists sampled the falls. Despite having no sunlight, almost no oxygen, and temperatures that would freeze most living things solid, the water teemed with microbial life. These weren't just any microbes, they were survivors, thriving in conditions so harsh they might as well be another planet. The discovery sent ripples through the scientific community. If life could cling on here, in what's essentially a frozen time capsule, what did that mean for the icy moons of Jupiter and Saturn? Places like Europa, with its vast subsurface ocean, suddenly seemed like prime real estate in the search for extraterrestrial life. Blood Falls didn't just rewrite the rules of where life could exist, it gave us a blueprint for how it might endure in the cosmos, hidden beneath miles of ice, waiting for its chance to bleed into the light. And that's the magic of geology. It doesn't just show us where we've been, it points to where we might go next. Imagine a world where continents could move not just inch over millennia, but wander the planet like colossal rafts, carrying entire ecosystems with them. That's exactly what German scientist Alfred Wegener proposed in 1912, and it nearly cost him his career. At the time, geology was ruled by a simple belief: Earth's crust was fixed in place, permanent as a statue. So when Wegener pointed out that the coastlines of South America and Africa fit together like puzzle pieces, or that identical fossils of ancient ferns and reptiles appeared on continents now separated by vast oceans, his colleagues laughed. They called it pseudoscience, a fantasy unworthy of serious study. But Wegener saw what others refused to: a planet alive with motion, its surface constantly rearranged by forces deeper than anyone dared imagine. The proof lay hidden beneath the ocean. In the 1950s and 60s, sonar mapping revealed something astonishing: a 40,000-mile-long mountain range snaking through every ocean, taller than the Alps in places, yet entirely underwater. These mid-ocean ridges weren't just geological quirks, they were factories where molten rock surged upward, creating new seafloor that spread outward like a conveyor belt. Even more telling were the magnetic stripes flanking these ridges, bands of rock that alternated between normal and reversed polarity, mirroring Earth's shifting magnetic field over millions of years. The pattern was unmistakable. The seafloor was moving, carrying continents with it. This was the smoking gun Wegener never lived to see. His theory of continental drift, once ridiculed, became the foundation of plate tectonics. The revolutionary idea that Earth's crust is a patchwork of giant slabs, constantly jostling, colliding, and diving beneath one another. Suddenly, everything made sense: why earthquakes cluster along certain lines, why volcanoes dot the Pacific like a ring of fire, even why the Himalayas soar skyward as India plows into Asia. Geology was no longer a collection of local curiosities. It became a global story, one where a rock in Brazil could whisper secrets about a mountain in Namibia. But here's what's truly humbling. Wegener didn't just change science, he changed how we see our planet. Before him, Earth was a static stage where life played out. After him, it was a dynamic, ever-shifting canvas, where the ground beneath our feet is just a fleeting arrangement in a dance that's been going on for billions of years. And the next time you look at a map, remember, those continents aren't fixed. They're travelers on an epic journey, and we're just along for the ride. Deep in the Karakum Desert of Turkmenistan, where the sands stretch endlessly under a blistering sun, there's a hole in the ground that refuses to close, a gaping maw of fire locals call the door to hell. This isn't some ancient myth or supernatural phenomenon. It's a very real, very accidental monument to humanity's occasional clumsiness with the planet's hidden volatile forces. Back in 1971, Soviet geologists were drilling for natural gas when the ground beneath their rig gave way, collapsing into an underground cavern filled with methane. Fearing the gas would spread and poison nearby villages, they made a decision: light it on fire. They assumed the flames would burn out in a few weeks. 50 years later, the crater still rages, a 30-meter-wide pit of roaring flames that glow like embers against the desert night. But what started as a mistake became something far more extraordinary, a natural laboratory for life's most tenacious survivors. Scientists who ventured to the crater's edge discovered something astonishing: microbes thriving in the superheated soil around the flames, where temperatures soar past 1,000 degrees Fahrenheit. These weren't just any bacteria, they were extremophiles, organisms evolved to flourish where nothing should survive. The door to hell, it turned out, was a portal to understanding how life might exist in the most hostile corners of the universe. The implications ripple far beyond Turkmenistan. If microbes can endure the inferno of a gas crater, what does that mean for the search for life on planets like Venus, where surface temperatures melt lead, or Mars with its subterranean lava tubes? The Darvaza crater forced scientists to expand their definition of habitable. Life, it seems, doesn't just cling to comfort, it seizes opportunity, adapting to environments we once dismissed as sterile. Yet the crater's flames also tell a darker story. They're a stark reminder of the planet's vast, untapped reservoirs of fossil fuels and the unintended consequences of extracting them. Every flicker of fire is methane burning, a greenhouse gas far more potent than carbon dioxide. In that sense, the door to hell isn't just a geological curiosity. It's a symbol of the delicate balance between discovery and destruction, a warning etched in fire about what happens when we pry too carelessly into Earth's secrets. And perhaps that's the real lesson here. Geology isn't just about uncovering the past, it's about confronting the consequences of our present. The Darvaza crater, with its endless flames and stubborn microbes, is a paradox, a place of ruin that somehow births new understanding. It reminds us that even our mistakes can become windows into the unknown, so long as we're willing to look into the fire and ask, what else are we missing? Deep in the steamy jungles of Costa Rica, where vines twist around ancient trees and howler monkeys fill the air with their eerie calls, lie some of archaeology's most perplexing treasures, the stone spheres of Diquis. Scattered across the landscape like marbles dropped by some long-forgotten giant, these orbs range in size from a few inches to over 8 feet in diameter, with the heaviest tipping the scales at a staggering 16 tons. Their surfaces are so perfectly smooth, so precisely round, that when they were first rediscovered in the 1930s during banana plantation excavations, workers assumed they must contain hidden gold. But when some were cracked open, all they revealed was solid stone, and a mystery that has endured for centuries. Who crafted these spheres and why? The answer, like so much of pre-Columbian history, is lost to time. The indigenous Boruca, Taraba, and other local cultures left no written records, and Spanish colonizers paid little attention to the stones, dismissing them as relics of a primitive past. What we do know is that the spheres were carved from gabbro, a hard volcanic rock or limestone, using tools made from other stones and sand as an abrasive. The level of precision is astonishing. Some spheres deviate from perfect roundness by less than 2 millimeters, a feat that would challenge modern sculptors with laser-guided tools. But here's where geology steps in to deepen the mystery. The stone's composition tells a story far older than the hands that shaped them. Gabbro and limestone are erosion-resistant, which is why these spheres survived centuries of tropical rains and river floods. Yet their original source was likely ancient riverbeds, where the raw material tumbled and smoothed naturally over eons before being hauled to their final resting places. By studying the spheres, geologists unlocked clues about Costa Rica's shifting waterways, rivers that dried up or changed course long before humans arrived. Theories about their purpose range from the practical to the celestial. Some archaeologists suggest they were status symbols for chiefs, markers of territorial boundaries, or even primitive currency. Others propose a more cosmic connection. Their arrangement in lines or clusters might mirror star patterns or solstice alignments, turning the landscape into a giant astronomical calendar. One tantalizing clue comes from a site where spheres were found placed at the foot of staircases leading to circular plazas, as if guiding the way for ceremonial processions. What makes these spheres truly extraordinary, though, is how they bridge disciplines. Archaeologists study their cultural significance, while geologists examine their mineral makeup to reconstruct ancient environments. Together, they paint a picture of a people deeply attuned to their world, artisans who selected stones not just for their beauty, but for their endurance, as if they knew their creations would outlast empires. And perhaps that's the most haunting thought of all. These spheres were meant to speak across time. Without a single written word, they tell us that precision, artistry, and a reverence for the Earth's materials are as old as humanity itself. The mystery of their purpose may never be solved, but their silent perfection remains a testament to the ingenuity of a civilization that understood one truth: some legacies are carved in stone. There's a sound that haunts the world's deserts, a low, resonant hum, almost like a distant choir, rising from the dunes when the wind blows or a hiker slides down the slopes. For centuries, those who heard it swore it was the work of spirits, trapped in the sands and wailing to be freed. Marco Polo himself wrote of hearing demonic drums in the Gobi Desert, while Bedouin legends spoke of jinn singing beneath the shifting grains. But the truth behind these so-called singing sands is no less magical. It's a perfect storm of physics and geology, where tiny grains of sand become instruments in Earth's most unexpected symphony. The secret lies in the sand itself, not just its composition, but its shape and size. Scientists discovered that only dunes with grains of nearly identical diameter, polished smooth by endless tumbling in the wind, can produce these eerie tones. When disturbed, these uniform grains slide past one another in synchronized waves, creating vibrations that amplify through the dune like the strings of a cello. The drier the sand, the clearer the sound, which is why the loudest songs often echo across deserts like the Sahara or the Rub al Khali, where humidity rarely interferes with the grain's harmonic dance. But this phenomenon isn't confined to deserts. On certain beaches, like the shores of Lake Michigan or the coast of Scotland, wet sand can squeak underfoot with a similar principle at work. The difference in pitch from deep desert drones to high-pitched beach chirps comes down to grain size and the speed of the vibrations. Smaller grains move faster, producing sharper sounds, while larger grains create deeper, more resonant tones. The implications of this discovery stretch far beyond solving an ancient mystery. Geophysicists realized that understanding these acoustic properties could save lives. By analyzing the singing of snow grains in alpine regions, researchers improved avalanche prediction models, listening for subtle changes in pitch that signal unstable layers beneath the surface. Even NASA took note when the Mars rover analyzed the red planet's soil. Scientists listened for any hint of vibrational harmony, a clue that Martian sands might share Earth's peculiar musicality. What's most poetic, though, is how these sands blur the line between science and art. A dune's song isn't random noise, it's a chord, often hitting a musical note between F and A. In Mongolia's Kongorin Els dunes, the sound can last for several minutes, swelling to a volume loud enough to drown out conversation. It's as if the Earth itself is reminding us that beauty and precision exist even in the most barren places, that a handful of sand, when arranged just right, can hold a melody older than human history. And perhaps that's the real lesson here. Sometimes the mysteries that captivate us most aren't just puzzles to solve. They're invitations to listen, to wonder, and to hear the planet's hidden music. Deep in the highlands of Cameroon, where mist clings to volcanic peaks and the air hums with the quiet of an ancient landscape, two lakes hold a deadly secret. They look peaceful, calm waters reflecting the sky, ringed by lush greenery. But beneath that stillness lurks an invisible threat, one that erupted with terrifying force on August 21, 1986. That night, Lake Nyos, a crater lake formed in the blast zone of a long-dormant volcano, did something almost unimaginable. It exploded not with fire or lava, but with a suffocating wave of carbon dioxide. The gas had been building for centuries, seeping up from magma chambers deep below, dissolving silently into the lake's depths like bubbles in a soda bottle. Under pressure, the water held it captive until something disturbed the balance. Maybe it was a landslide, a small earthquake, or simply the slow churn of nature. Whatever the trigger, the lake suddenly flipped, its layers mixing like a shaken drink. In an instant, a colossal bubble of CO2 burst from the water, racing downhill as an invisible tsunami. Heavier than air, the gas hugged the ground, flooding valleys at nearly 60 miles per hour. Villages in its path had no warning. People collapsed mid-step, their lungs starved of oxygen. By dawn, over 1,700 lives were lost, along with every animal for miles, all without a single scorch mark or shattered window. This wasn't an act of malice or negligence. It was geology in its rawest form, a phenomenon so rare scientists didn't even have a name for it until Nyos made history. They call it a limnic eruption now, and it's one of Earth's rarest disasters. But what makes Nyos and its sister lake, Mono One, where a similar eruption killed 37 people 2 years earlier, so chilling isn't just their lethality. It's their ordinariness. These aren't fiery calderas or gaping fissures. They're unassuming lakes, the kind you might pass without a second glance. Yet in the aftermath, geologists turned detectives, piecing together how to prevent future tragedies. Their solution was as elegant as it was unconventional: giant soda straws. Teams installed vertical pipes in Nyos and Mono One, stretching from the surface down to the gas-rich depths. By slowly pumping water from the bottom, they allowed CO2 to bubble out harmlessly, like letting air escape from a tire. Today, these degassing systems hum quietly, monitored by sensors that track gas levels in real time. It's a stark reminder that geology isn't just about understanding the past. It's about shaping the future, but Nios left behind a deeper lesson. Most natural disasters, earthquakes, volcanoes, hurricanes, announce themselves with fury. Limnic eruptions are silent. They remind us that danger doesn't always roar. Sometimes it's the quietest places that hold the greatest risks, waiting for the moment when the Earth decides to exhale. And in that invisible breath lies a warning: respect the planet's hidden forces, because not all monsters come with teeth, some come without a sound. Tucked away in New York's Chestnut Ridge Park, where waterfalls cascade over mossy cliffs and the air smells of damp earth, there's a flame that refuses to die. Behind a curtain of falling water, a small but steady fire flickers, its orange glow defying the rushing currents that should snuff it out. This is the eternal Flame Falls, a natural wonder where geology and chemistry conspire to create something that feels almost magical. But the truth behind this eternal flame is far more fascinating than any myth. It's a tiny window into the vast, hidden world of underground gases that shape our planet in ways we're only beginning to understand. The flame owes its persistence to a natural gas seep, where methane and other hydrocarbons escape from deep within the Earth's crust through cracks in the shale bedrock. These gases formed over millions of years as organic matter decomposed under heat and pressure rise to the surface, meeting just enough oxygen to ignite. Early settlers stumbling upon such flames often saw them as divine signs or gateways to the underworld. But today, scientists recognize them as valuable clues, not just to the planet's energy reserves, but to its delicate climatic balance. What makes these seeps so revealing is their duality. On one hand, they're natural fuel sources, hinting at untapped reservoirs of energy beneath our feet. Geologists study their locations to map potential drilling sites, tracing the invisible pathways of gas through rock layers. On the other hand, they're stark reminders of methane's power as a greenhouse gas, over 80 times more potent than carbon dioxide at trapping heat in the short term. When these seeps release methane unchecked, they contribute to the warming of our atmosphere, making them critical to climate research. But here's the twist: not all natural flames are created equal. Some, like Azerbaijan's Yana Dag, where a hillside has burned continuously for centuries, are fed by massive gas deposits. Others, like the eternal Flame Falls, are far more delicate, their survival dependent on the precise interplay of gas flow, water, and ventilation. Scientists have even discovered that the fall's flame isn't purely natural. Early park visitors likely lit it long ago, and the gas seep simply keeps it alive. Yet this human touch doesn't diminish its scientific value. If anything, it underscores how geology and human curiosity are forever intertwined. The real magic of places like this isn't just in their defiance of nature's rules. It's in what they teach us about Earth's hidden systems. These flames are like pilot lights for the planet's inner workings, reminding us that beneath the serene surface of forests and waterfalls, there's a dynamic, ever-changing world of energy and chemistry. And as we grapple with the challenges of climate change and energy sustainability, these eternal flames offer a humble lesson. Sometimes the answers we seek are already burning right in front of us, if we know where to look. The desert is a place of stillness where time itself seems to slow under the weight of the sun. Yet in Death Valley, some rocks refuse to stay put. For decades, the trails left by these sailing stones carved intricate patterns across racetrack pliers, cracked mud, as if invisible hands had dragged them. Early theories ranged from the whimsical to the wild: dust devils, magnetic fields, even pranksters under cover of darkness. But the truth, when it finally emerged, was a masterclass in how Earth's subtlest forces can create its most baffling spectacles. The breakthrough came when scientists turned detectives, planting time-lapse cameras and miniature GPS units around the playa. What they captured was a ballet of ice and wind so delicate it bordered on poetic. On rare winter nights when rain pooled on the lakebed and temperatures plunged, the water froze into paper-thin sheets. Come morning, sunlight melted the ice just enough to fracture it into vast floating panels. Then, with a breeze no stronger than a sigh, sometimes just 5 miles per hour, these ice rafts began to glide, nudging rocks along like ships in tow. The stones, some weighing as much as a piano, inched forward at speeds barely perceptible to the human eye, their paths scribbled into the mud by the whims of physics. But here's what makes this discovery revolutionary. It wasn't just about solving a desert riddle. It rewrote our understanding of how objects move across landscapes, even beyond Earth. Researchers realized that if thin ice could mobilize boulders in Death Valley, similar processes might shape the surfaces of other worlds. On Mars, where frost forms overnight and winds whip across barren plains, could ice-rafted rocks explain mysterious tracks spotted by orbiters? The sailing stones became a Rosetta Stone for planetary scientists, proving that even the gentlest forces given the right conditions can leave dramatic scars. Yet the deeper lesson lies in the fragility of the phenomenon. The player's magic requires a precise recipe, just enough water to form ice, but not so much that it drowns the rocks, sunlight strong enough to melt the ice partially, but not completely, winds feeble enough to avoid shattering the ice, but steady enough to push it. It's a reminder that some of Earth's greatest mysteries aren't forged in cataclysms, but in the quiet, fleeting moments when elements align just so. And if rocks can sail across a desert on sheets of ice thinner than a smartphone, what other impossible-seeming movements might we be missing, not just here, but on worlds we've yet to explore? Perhaps that's the true gift of the sailing stones. They don't just challenge what we know, they challenge how we look. In a universe where grandeur often shouts, sometimes the most profound truths whisper, waiting for us to lean in close. In the quiet town of Knaresborough, England, where medieval ruins cling to cliffs above the River Nid, there's a well that seems to defy time itself. Hang a teddy bear, a bicycle, or even a coffee pot beneath its dripping waters, and within months the object transforms, encased in a stony shell as if frozen mid-motion. For centuries, locals believed the petrifying well held supernatural powers, a cursed spring that turned living things to stone. But the truth behind this eerie transformation is a spectacular demonstration of chemistry at work, one that mirrors Earth's own fossilization processes and even holds secrets for modern industry. The magic, or rather, the science, lies in the water's extraordinary mineral content. As rainwater seeps through the limestone hills surrounding Knaresborough, it dissolves calcium carbonate and other minerals, turning into a supercharged solution. When this water emerges at the well's mossy mouth, it cascades over objects hung below, and something extraordinary happens. As each droplet evaporates, it leaves behind an infinitesimally thin layer of minerals. Over weeks and months, these layers accumulate, encasing the object in a rock-hard shell. It's not true petrification, like the million-year process that turns dinosaur bones to stone, but the effect is strikingly similar, a sped-up snapshot of how nature preserves organic matter over geologic time. What fascinates scientists isn't just the well's novelty, but its uncanny resemblance to natural mineral deposits worldwide. In Iceland's hot springs, for example, silica-rich waters create living stone formations around twigs and leaves, while in Yellowstone, thermal pools coat pine cones in glittering opal. The petrifying well is like a controlled laboratory for these phenomena, where researchers can observe calcification in real time. By studying how minerals bond to different surfaces, from porous feathers to smooth plastic, they've unlocked clues about how fossils form, why some ancient organisms preserve in exquisite detail while others crumble to dust. But the well's lessons aren't confined to the past. Modern engineers have taken cues from its natural coating process to develop advanced industrial techniques. Imagine spray on ceramic coatings that protect jet engines from extreme heat, or medical implants designed to bond with human bone by mimicking the well's mineral layering. Even artists have borrowed the method, using mineral-rich solutions to grow stone sculptures without a chisel. The petrifying well, once a source of superstition, has become a muse for innovation, proof that nature's quirks often hold blueprints for human ingenuity. Yet the well's most enduring gift might be its reminder of time's fluidity. A teddy bear turned to stone in months sits beside fossils formed over millennia, blurring the line between artifact and geology. It's as if the well whispers a quiet truth. The boundary between organic and mineral, fleeting and eternal, is far thinner than we think. And in that whisper lies a challenge to look closer, because even the strangest natural wonders might be teaching us how to shape the future. Off the coast of southern Japan, where the Pacific's blue deepens into darkness, lies a secret written in sand, one so intricate, so impossibly precise, that when divers first stumbled upon these underwater crop circles in the 1990s, they assumed they'd found the handiwork of extraterrestrials. Etched into the seafloor in near-perfect symmetry, these swirling patterns stretched up to 7 feet across, their ridges and valleys forming geometric masterpieces worthy of a master sculptor. But the truth was far more astonishing. These weren't alien messages or ancient ruins. They were love letters painstakingly crafted by a creature no bigger than a human hand, the pufferfish. For decades, the circles remained a marine enigma, dismissed as odd currents or buried artifacts, until a team of scientists with cameras decided to watch. What they captured was a revelation. A male pufferfish, small and spiny, fluttered above the sand like an artist possessed, using nothing but his body as a chisel. With frantic beats of his fins, he carved trenches radiating outward like sunbeams, then painstakingly arranged broken shells along the inner ridges like decorations on a cake. The entire process took days, a marathon of exertion for a creature that could fit in a teacup, and the purpose, seduction. When a female pufferfish swam by, she'd inspect the design, her movements slow and deliberate. If the grooves met her standards, their symmetry, their depth, she'd deposit her eggs at the center, allowing the male to fertilize them before she vanished back into the blue. But here's where geology enters the story. These nests aren't just romantic gestures, they're feats of ecological engineering. The ridges and valleys alter water flow, creating microcurrents that protect the eggs from silt and predators. Over time, as generations of pufferfish repeat this ritual, their collective labor reshapes the seafloor itself, turning barren sand into a mosaic of fertile nurseries. It's a living example of how life doesn't just adapt to landscapes, it designs them. The implications ripple far beyond Japan. Similar patterns have since been spotted off Australia and the Mediterranean, suggesting this behavior might be more widespread than we ever imagined. Marine biologists now study these circles to understand how small creatures can have outsized impacts on their environments, while geologists see them as a modern parallel to ancient trace fossils, the preserved burrows and nests of prehistoric organisms. If a pufferfish can sculpt the seafloor today, what other animal architects might have left hidden marks in Earth's geological record? What's most humbling, though, is the scale. These circles exist in a world we rarely see, crafted by a creature we often overlook. They remind us that artistry and ingenuity aren't human monopolies. They're woven into the fabric of life itself. And somewhere beneath the waves, a tiny fish with a big heart is still out there, writing poetry in sand, one fin stroke at a time. Deep in the heart of the Peruvian Amazon, where the air is thick with the scent of damp leaves and the calls of howler monkeys echo through the canopy, there's a river that defies all logic. This isn't just any waterway, it's a tributary that boils. At Mayantayacu, the Shanay Tempishka, which translates to boiled with the heat of the sun, churns with temperatures reaching 200 degrees Fahrenheit, hot enough to steep tea or, tragically, cook small creatures alive that wander into its currents. For generations, indigenous Ashaninka people spoke of the river's lethal warmth, but to outsiders, the idea seemed impossible. After all, boiling water requires volcanic heat, and the nearest active volcano lies over 400 miles away. The mystery deepened when geologists arrived, expecting to debunk the legends. Instead, they found themselves standing at the banks of a river that genuinely simmered, its steam curling into the jungle air like a cauldron's breath. The key to its heat lay not in magma chambers or fiery fissures, but in something far more subtle, a network of geothermal faults. Here, rainwater seeps deep into the Earth's crust through cracks in the bedrock, where it's superheated by the planet's inner warmth before surging back to the surface under pressure. It's a natural pressure cooker, fueled by the same forces that drive hot springs and geysers, just on a scale no one had documented in a rainforest before. This discovery didn't just solve a local riddle, it rewrote the rules of geothermal activity. Scientists had long assumed such extreme heating required the dramatic energy of volcanoes or tectonic collisions. The boiling river proved that Earth's heat could express itself in quieter, more diffuse ways, turning unassuming landscapes into geological marvels. Suddenly, other, impossible hot springs from the Amazon basin to the Congo's rainforests began making sense. The planet, it seemed, had been hiding its warmth in plain sight, waiting for us to look beyond textbook assumptions. But the river's lesson isn't just scientific, it's cultural. The Ashaninka, who have lived alongside this deadly current for centuries, understood its power long before geologists arrived. They revered it as a sacred site, a place where the spirit world brushed against the physical. Modern researchers now work alongside these communities, blending traditional knowledge with cutting-edge science to map the river's hidden plumbing. It's a partnership that reveals a deeper truth. Sometimes the most profound discoveries begin not with instruments, but with stories passed down through generations. And perhaps that's the real wonder here. The boiling river isn't just a curiosity, it's a bridge between worlds. It reminds us that Earth's mysteries aren't always buried in remote wastelands or ocean depths. They can thrive in the heart of a jungle, in a place where water burns and science humbles itself before nature's ingenuity. So the next time someone claims something's impossible, remember, there's a river in the Amazon that boils without fire, defying logic to remind us how much we have yet to learn. Beneath the arid plains of Chihuahua, Mexico, lies a chamber so surreal, it feels like stepping into a frozen cathedral of light. The Naka Mine's Cave of Crystals is a hidden world where translucent pillars of selenite, some as long as a school bus and as heavy as a humpback whale, crisscross the cavern like the ribs of a giant crystal beast. These aren't just minerals, they're time capsules, each one a record of 500,000 years of patient chemistry, growing at a rate slower than the growth of human hair. What makes these crystals so extraordinary isn't just their size, but the hellish nursery that birthed them. For millennia, the cave sat flooded with scorching, mineral-rich water heated by magma chambers below. The conditions were otherworldly, temperatures hovering near 120 degrees Fahrenheit with humidity so thick, unprotected explorers risked their lungs filling with fluid after just minutes inside. Yet in this hostile environment, gypsum molecules in the water link together atom by atom, forming the flawless, sword-like crystals that now dazzle scientists. The cave's discovery in 2000 wasn't just a geological marvel, it became a blueprint for life's potential in the cosmos. Researchers realized that nacre's extreme heat, mineral soup, and isolated pockets mimicked conditions on moons like Europa or Enceladus, where icy crusts hide subsurface oceans. If microbes could survive in nacre's crystal veins, and studies suggest some have, trapped in tiny fluid bubbles within the selenite, then why not in similar alien environments? Astrobiologists now study these crystals like alien artifacts, probing for extremophile bacteria that rewrite the rules of where life can exist. But nacre holds another secret: its crystals are dying. When miners pumped out the groundwater to access silver and lead deposits, they unintentionally drained the cave's lifeblood. Without the mineral bath that sustained them, the crystals began to degrade, their surfaces clouding like aging glass. Today, scientists race to document the cave's wonders before they vanish, using 3D scanners and microbial swabs to preserve its legacy. It's a bittersweet reminder that some of Earth's greatest treasures are as fragile as they are ancient, and that discovery often comes with a cost. Perhaps that's the cave's most profound lesson. These crystals didn't just grow, they endured, shaped by forces as patient as they were relentless. They whisper of a truth that spans from Earth's depths to distant planets. Beauty and resilience often thrive in the unlikeliest places, waiting for the moment when light finally finds them. The shores of the Dead Sea look like a battlefield, but instead of craters from bombs, the land is pockmarked with gaping holes, some as deep as a 10-story building. These aren't ordinary sinkholes, they're voracious pits that materialize without warning, swallowing roads, date palms, even entire chunks of coastline. Over 7,000 of them dot the landscape now, a number that grows by hundreds each year, transforming what was once solid ground into a geological minefield. And every single one is a stark reminder of how human interference can unravel the delicate balance of nature in ways no one saw coming. The culprit. A vanishing sea, the Dead Sea, the saltiest body of water on Earth, has been shrinking at an alarming rate, dropping over 1 meter per year as water from its main tributary, the Jordan River, gets diverted for agriculture and drinking water. But here's the twist: it's not the receding water itself that's causing the sinkholes. It's what's hiding beneath. For millennia, the Dead Sea's briny waters acted like a cap, sealing underground layers of salt left behind by ancient evaporation. Now, as the shoreline retreats, fresh water from rainfall and underground springs seeps into the exposed salt deposits, dissolving them like sugar in tea. The result: massive underground cavities that collapse without warning, leaving behind these apocalyptic pits. What makes these sinkholes so unnerving isn't just their scale, it's their unpredictability. Unlike traditional sinkholes, which form slowly over years, Dead Sea sinkholes can appear overnight. 1 minute, the ground seems stable. The next, it's a gaping maw. Local guides tell stories of hearing eerie cracks before the earth gives way, like the land itself is groaning under the weight of change, and the damage isn't just cosmetic. These craters have forced hotels to relocate, toppled power lines, and rerouted highways, turning the region into a real-life game of geological roulette. Yet amid the destruction, scientists see something extraordinary: a living laboratory. The Dead Sea's sinkholes offer a rare glimpse into how Earth's surface responds to rapid environmental shifts. By studying their patterns, geologists can predict where the next collapse might occur, potentially saving lives in other water-stressed regions facing similar fates. There's even a bizarre silver lining. Some sinkholes have filled with fresh water, creating unexpected oases where microorganisms thrive in extreme conditions, offering clues about life's adaptability in harsh environments. But the most haunting lesson here isn't scientific, it's philosophical. The Dead Sea sinkholes are a monument to unintended consequences. A century ago, no one imagined that diverting river water for farms and cities could trigger an epidemic of collapsing land. Yet here we are, watching the ground literally vanish beneath our feet. It's a sobering reminder that when we alter nature's balance, the planet often responds in ways we can't foresee. And sometimes the bill comes due not in dollars or droughts, but in holes so deep they seem to lead straight to the Earth's memory of what we've lost. High in the rugged wilderness of southeastern Oregon, where the horizon stretches uninterrupted and the wind carries the scent of sagebrush, Steens Mountain guards one of geology's most electrifying secrets. This ancient volcanic massif isn't just a scenic backdrop, it's a time machine. It's layers of basalt frozen mid-sentence in a story written by Earth's magnetic field. 16 million years ago, as lava oozed from fissures and cooled into rock, something extraordinary happened deep within the planet. The magnetic field, that invisible shield that guides compass needles and protects life from solar radiation, did the unthinkable. It flipped. And the rocks of Steens Mountain captured every moment like a geological tape recorder. What makes this record so astonishing isn't just the reversal itself, it's the speed. For decades, scientists assumed these flips were leisurely affairs, taking thousands of years as the planet's molten iron core slowly rearranged itself. But the Steens Mountain rocks told a different story. Their magnetic minerals, aligned like tiny compass needles as the lava cooled, revealed the field reversed at a breakneck pace, sometimes shifting by as much as 6 degrees per day. To put that in perspective, if you'd been standing there with a compass during the flip, the needle could have spun a full circle in just 2 months. It's as if Earth's magnetic engine briefly sputtered, then roared to life in reverse. This discovery didn't just rewrite textbooks, it sent shockwaves through fields from geology to astrophysics. If the magnetic field can reverse so abruptly, what does that mean for modern technology? Our satellites, power grids, and navigation systems all rely on a stable magnetic field. A rapid flip today could unleash chaos, frying electronics and exposing planes to dangerous radiation. Suddenly, understanding Steens Mountain's rocks became a matter of planetary preparedness. But the mystery runs deeper. Why does the field reverse at all? The leading theory points to turbulence in Earth's outer core, where molten iron swirls like a storm, generating the magnetic field through a process called the geodynamo. Sometimes these swirling currents trip over themselves, triggering a cascade that flips the field's polarity. The Steens Mountain data suggests these events aren't smooth transitions. They're more like cosmic hiccups, moments when the planet's inner machinery stutters before finding a new equilibrium. What's truly humbling, though, is how much we still don't know. The rocks of Steens Mountain are just one page in a story spanning billions of years. Elsewhere, from the volcanic cliffs of Iceland to the ocean floor's magnetic stripes, Earth keeps leaving clues about its restless magnetic personality. And with each discovery, we're reminded that even the ground beneath our feet isn't as solid as it seems. It's part of a dynamic, ever-changing system, one that might just flip the script again when we least expect it. In a quiet corner of Romania's Costesti village, the rocks are alive, or at least they seem to be. Meet the Trovent's odd, bulbous stones that swell when it rains, some doubling in size over decades, others sprouting smaller, offspring like geological buds. To the villagers who have lived alongside them for generations, these stones have always been peculiar, almost magical. But to geologists, they're a window into one of nature's most ingenious tricks, a rock that builds itself. The secret lies in their core. Trovents aren't ordinary boulders. They're sandstone formations packed with a rare cement-like mineral called calcium carbonate. When rainwater seeps into their porous surface, it triggers a chemical reaction. The carbonate dissolves, then re-hardens as the water evaporates, adding microscopic layers like tree rings. Over time, this cycle swells the stones outward, their surfaces wrinkling into lumpy shapes that resemble everything from brains to loaves of bread. Some even develop limbs, protruding nodules that eventually snap off under their own weight, creating smaller stones that repeat the process. It's as if the landscape itself is breathing, growing stone by stone. But here's where the science gets revolutionary. Researchers studying Trovents realize this self-growth mechanism mirrors how some modern materials, like self-repairing concrete, are designed to work. Imagine infrastructure that patches its own cracks by reacting to rainwater, or buildings that strengthen over time instead of crumbling. The Trovents blueprint, using natural minerals and water to heal and expand, could slash maintenance costs for bridges and roads while reducing the need for resource-heavy repairs. Already, labs are experimenting with synthetic versions of the Trovents mineral matrix, hoping to replicate nature's patience on human timelines. Yet the stone's mystery runs deeper than engineering. Found primarily in a small region of Romania, their exact origins are debated. Some geologists argue they're ancient sandstone concretions, formed millions of years ago when mineral-rich groundwater cemented loose sediment. Others suggest they're the product of long-vanished seismic activity, their nuclei forged in the pressure of shifting tectonic plates. Whatever their birth, their growth is undeniably alive in a geological sense, a slow dance of chemistry and time, where water isn't just a force of erosion but a sculptor. What's most captivating, though, is how Trovents blur the line between the organic and inorganic. They challenge our assumptions about what it means to grow. Trees do it with cells, crystals do it with lattices. These stones do it with rain and minerals, rewriting the rules right under our feet. And in that quiet village where Trovents bulge silently after every storm, there's a humbling reminder. Sometimes the most extraordinary things aren't the ones that shout their wonders, but those that simply persist, patient and unnoticed, until science catches up to their secrets. Off the coast of the Bahamas, where turquoise waters fade into the abyss, lie gateways to another world, vertical chasms so deep and dark they swallow the light whole. These are the blue holes, nature's underwater time capsules, and among them, Steens' blue hole reigns supreme, plunging over 600 feet straight down, deeper than the Eiffel Tower is tall. This submerged sinkhole is more than a diver's challenge. It's a portal to Earth's past, its oxygen-starved depths preserving secrets that would vanish almost anywhere else. What makes these blue holes so extraordinary isn't just their depth, it's what's trapped inside. Cut off from currents and sunlight, their lower layers become virtual museums of ancient climate. Sediments settle into razor-thin bands, each one a snapshot of a different era. Some are studded with the bones of extinct creatures, like the giant tortoises and crocodiles that once roamed the Bahamas when sea levels were lower. Others hold pollen grains from long-vanished forests, whispering stories of how the landscape shifted over millennia, but the real treasure lies in the chemistry. Like tree rings, these layers record fluctuations in temperature, rainfall, and even hurricane frequency, offering scientists a playbook of how Earth's climate has behaved and how it might change again. The key to unlocking this archive, hydrogen sulfide, this toxic gas produced by bacteria in the hole's stagnant depths, creates a lethal barrier for most life, but a perfect preservative for organic matter. Below this dead zone, artifacts stay pristine for centuries. divers have recovered everything from fossilized bird eggs to prehistoric pine cones, all untouched by decay. Even human relics surface, occasionally evidence that the Lucayan people, the Bahamas' original inhabitants, once ventured into these caves before they flooded at the end of the last ice age. Yet the blue hole's greatest gift might be their hurricane diaries. When a major storm strikes, it churns up sand and debris, depositing a distinct layer in the hole's sediment. By core sampling these strata, researchers can trace hurricane patterns back thousands of years, long before weather records existed. What they've found is startling: periods of intense activity followed by eerie calm, suggesting our current era of superstorms might not be unprecedented, just part of a cycle we're only beginning to understand. But the clock is ticking. Rising sea levels and ocean acidification threaten to erase these fragile records. As saltwater creeps deeper into the holes, it disrupts the delicate chemistry that's preserved their secrets for so long. Scientists now race to document them, knowing each expedition might recover data that vanishes within decades. It's a sobering thought. These ancient wells, which have witnessed ice ages and empires, could surrender their last clues just as we learn how to read them. And perhaps that's the real lesson of the blue holes. They remind us that Earth's memory is vast but fragile, written in layers we're only starting to decipher. Every dive into their depths is like turning a page in a book that's been silently writing itself for millennia. One that might hold answers to our future, if only we listen before the waves close over it for good. From the air, Namibia's Namib Desert looks like it's been struck by a cosmic shotgun. Millions of near-perfect circular patches dot the landscape, each a barren halo of red earth fringed by a stubborn ring of grass. These are the fairy circles, one of Earth's most mesmerizing natural puzzles. For decades, their origins sparked fierce debate, with theories ranging from toxic gases rising from below to UFO landing marks. But the truth, as it often does, lies in an elegant collision of biology and geology, a dance between termites and thirsty roots that paints the desert with polka dots visible from space. The first clue came from the termites themselves. Scientists noticed that certain sand termites, tiny engineers of the underground, were unusually active in the circles. These insects don't just chew wood, they're master landscapers, nibbling away at grass roots to create bare patches where water can pool just beneath the surface. In a land where rain is rarer than gold, these termite-made reservoirs become oases, sustaining colonies through droughts. But here's where it gets fascinating. The circles aren't just termite condos. They're part of a vast, self-regulating ecosystem. The grass ringing each circle acts like a sponge, its roots funneling moisture toward the center, while the bare patch reflects sunlight, cooling the ground and reducing evaporation. It's a perfect loop. Termites create the circle nurtures the termites, and the whole system stabilizes the desert's fragile water balance. Yet termites aren't the only players. Another theory argues that the circles emerge from pure plant competition. In this version, grasses wage silent warfare underground, their roots stealing water from neighbors until weaker plants die, leaving gaps that expand into rings. Computer models show how this tug of war can spontaneously generate patterns identical to fairy circles. No termites required. For years, these camps clashed, each convinced their explanation was the only one. But recent research suggests something revolutionary. Both could be right. In some regions, termites dominate. In others, plant competition rules. Sometimes they might even work together, with termites jump-starting circles that plants then maintain. What makes this mystery so profound isn't just solving a desert riddle, it's how these circles mirror patterns found across nature. From the hexagonal cracks of Arctic ice to the spaced-out mounds of Australian spinifex grass, similar shapes emerge again and again, as if Earth has a hidden blueprint for organizing life. The fairy circles are like a Rosetta Stone for these phenomena, showing how simple rules, competition for resources, cooperation for survival, can sculpt landscapes on a planetary scale. And perhaps that's the real magic here. These barren patches aren't accidents or anomalies. They're proof that even in the harshest places, life finds a way to carve order from chaos, writing its story in rings of grass and sand. The next time you see a pattern in nature, whether it's the swirl of a seashell or the branching of a river, remember Namibia's fairy circles. They're a reminder that the planet speaks in shapes, and sometimes the most ordinary marks on the land hold the most extraordinary secrets. Minnesota's Brule River holds a magic trick that would baffle even the most seasoned illusionist. At Judge C. R. Magny State Park, the river splits around a jagged rock, forming a twin waterfall known as the Devil's Kettle. The eastern cascade behaves as expected, tumbling 50 feet into a frothy pool below. But its western twin, it vanishes. Half the river's flow plunges straight into a gaping hole in the bedrock, a yawning, moss-lined throat that swallows thousands of gallons per minute without a trace. Throw a stick into the whirlpool and it's gone forever. Drop a GPS tracker and it winks off the map. Even neon dye, poured into the abyss by baffled hydrologists, disappears without resurfacing downstream. For decades, this waterfall has been geology's ultimate vanishing act, a riddle carved in stone and water. The Devil's Kettle isn't just a curiosity, it's a slap to modern science's face. Karst hydrology, the study of how water moves through soluble rock like limestone, usually has answers. We can map underground rivers, predict sinkholes, even trace water through labyrinthine caves. But this hole defies every rule. Seismic surveys, sonar scans, even cameras lowered into the chasm have failed to find an exit. The river should reappear somewhere, logically joining Lake Superior just a mile downstream. Yet dye tests there show no sign of the missing water. It's as if the Earth opened a secret backdoor, rerouting an entire river through some uncharted underworld. One theory suggests the water might dive deep, merging with ancient lava tubes left by the region's volcanic past. Minnesota's North Shore is built on billion-year-old basalt, rock so dense it's practically waterproof. But lava tubes' tunnels formed when molten rock surface cooled while its interior drained, could create hidden highways for water. If the kettle taps into one, the river might travel miles underground before emerging unseen, perhaps even feeding aquifers far from the park. Another idea points to faults. Fractures in the bedrock so vast they could swallow a river whole, channeling it through cracks too narrow for modern instruments to detect. Yet the most tantalizing clue comes from the river itself. In 2017, scientists measured the water volume above and below the falls, expecting a discrepancy. To their shock, the numbers matched perfectly. The missing water wasn't missing at all, it was rejoining the river somehow, just in a way invisible to all observation. This revelation didn't solve the mystery, it deepened it. How could thousands of gallons vanish and reappear without leaving a trace? The answer might lie in something as simple as turbulence, violent churning that disperses dye particles beyond detection, or something as complex as a subterranean network too intricate for current technology to map. What makes the Devil's Kettle so humbling isn't just the gap in our knowledge. It's the reminder that Earth still holds pockets of wonder even science can't crack. In an age where satellites map every inch of the planet, this waterfall whispers that some secrets remain stubbornly buried, and maybe that's for the best. Some mysteries aren't meant to be solved, they're meant to keep us curious, to remind us that no matter how much we learn, the world will always have one more trick up its sleeve. Off the coast of Mauritius, where the Indian Ocean shimmers in shades of turquoise and sapphire, there's a sight that defies logic: an underwater waterfall. From above, the illusion is breathtaking. Cascading currents of sand and silt tumble down the continental shelf like a submerged Niagara, vanishing into the abyss. But dive beneath the surface and the magic trick reveals itself. There's no actual waterfall here, no plunging water, no rocky ledge. Instead, this mesmerizing spectacle is a masterpiece of oceanography, where currents, sediment, and sunlight conspire to fool the eye. The secret lies in the island's unique geography. Mauritius sits atop an undersea plateau where shallow coastal shelves abruptly drop into the deep ocean. As powerful ocean currents sweep along the coastline, they drag fine grains of sand and silt from the island's volcanic shores, funneling them toward the shelf's edge. When these particles hit the steep drop-off, they sink like snowfall into the darker depths, creating flowing ribbons that mimic falling water. Sunlight amplifies the illusion. Shallow areas reflect bright blues and greens, while the deep channels absorb light, heightening the contrast between the falls and their surroundings. From the air, the effect is uncanny, as if the ocean itself is draining into a hidden drain. But this isn't just a visual marvel, it's a dynamic lesson in how the ocean sculpts our planet. The same currents that craft this illusion are constantly reshaping coastlines, carving canyons, and redistributing nutrients across the seafloor. Similar phenomena occur near the Bahamas' tongue of the ocean and Australia's Great Barrier Reef, where sediment slides create ghostly rivers in the deep. What makes Mauritius Waterfall special is its scale and clarity, offering a rare window into processes usually hidden beneath waves. The underwater waterfall also hints at a deeper truth. Our planet's most stunning illusions often have the most practical explanations. Sailors once mistook these currents for whirlpools or sea monsters, weaving myths to explain what science now decodes. Today, satellites and sonar maps reveal the mechanics behind the magic, showing how Earth's forces, wind, water, and gravity orchestrate these performances. Yet even with the science laid bare, the wonder remains. Somewhere between the known and the unknown, between the measurable and the miraculous, the ocean keeps its mysteries alive, reminding us that reality, when viewed from the right angle, can be just as enchanting as any myth. And perhaps that's the real beauty of Mauritius' vanishing cascade. It doesn't need supernatural explanations to captivate. It's proof that nature, left to its own devices, will always find ways to astonish, not by breaking the rules, but by playing them in ways we're still learning to see. So the next time you gaze at the ocean, remember, the most extraordinary sights aren't always the ones that shout. Sometimes they're the quiet deceptions, the ones that dare you to look twice. Legend says the Giant's Causeway was built by an Irish giant named Finn McCool, who tore up chunks of the Antrim coast to construct a path across the sea to Scotland, facing off against his rival Benandina. The towering basalt columns, stacked like a colossal staircase descending into the North Atlantic, certainly look like something only a mythic titan could craft. But the truth behind Northern Ireland's most iconic landmark is no less wondrous, a story written not by giants, but by fire, time, and the unforgiving laws of physics. Roughly 60 million years ago, this stretch of coastline was a seething battleground of a different kind. Molten lava, erupting from fissures in the Earth's crust, flooded the landscape in layer after layer, each one cooling slowly under the weight of the next. As these flows contracted, they fractured not randomly, but in a stunningly precise geometric ballet. The result, 40,000 interlocking hexagonal columns, some reaching nearly 40 feet high, their sides so straight and angles so sharp they seem chiseled by a master stonemason. What makes these formations so extraordinary isn't just their scale, it's their perfection. Hexagons are nature's most efficient shape for packing together without gaps, a pattern seen in honeycombs, soap bubbles, and even the cracks in drying mud. But the giant's Causeway takes this principle to an almost mathematical extreme. The columns vary from 4 to 8 sides, but 6 dominates, a testament to the lava's struggle to release stress evenly as it cooled. Scientists now recognize this as a textbook example of columnar jointing, a phenomenon that occurs when thick lava flows contract fractally, splitting into pillars as the rock shrinks. The Causeway's real gift to science, though, came when researchers realized these cliffs were more than a tourist attraction. They were a natural laboratory. By studying the columns' angles and spacing, geologists refined models of how materials fracture under thermal stress, insights that now inform everything from aircraft engine design to the construction of earthquake-resistant buildings. Engineers even mimic these natural fracture patterns to create stronger, lighter synthetic materials, proving that nature's blueprints often outshine human ingenuity. Yet the mysteries linger. Why do some columns curve like tree trunks while others stand arrow straight? How did slight variations in cooling rate produce such dramatic changes in column width? Even today, scientists debate the finer details, using everything from 3D scans to scaled lab experiments with drying cornstalk. Each answer peels back another layer, revealing how chaos and order dance together in the birth of a landscape. Standing on those cliffs today, with the wind howling and the sea crashing below, it's easy to see why ancient cultures reached for myth. The Causeway feels deliberate, almost purposeful. But the reality is far more thrilling, a reminder that the Earth's greatest artworks weren't sculpted by hands, but by the raw, unthinking forces of heat and time. And perhaps that's the most humbling lesson of all. Sometimes the most otherworldly beauty isn't magic at all. It's just physics, patiently arranging itself into something unforgettable. There's a place in Venezuela where the night sky refuses to stay dark, where lightning doesn't just strike, but becomes the sky's heartbeat. Over Lake Maracaibo, near the mouth of the Catatumbo River, a storm rages nearly 300 nights a year, unleashing up to 28,000 bolts of lightning in a single evening. This isn't just bad weather, it's the Catatumbo Lightning, a meteorological marvel so relentless, so predictable, that for centuries sailors used its flickering glow as a natural lighthouse, guiding ships through the Caribbean's treacherous waters. What makes this phenomenon so extraordinary isn't just its frequency, it's the perfect storm of geography and chemistry that fuels it. Lake Maracaibo sits in a unique topographic bowl, ringed by the Andes Mountains to the west and the Caribbean Sea to the north. Warm, moisture-laden winds from the sea collide with cooler air descending from the mountains, creating a near-constant updraft. But here's the twist. The lake's marshy shores leak methane, a byproduct of decomposing organic matter in the wetlands. As this gas rises, it ionizes the air, supercharging the atmosphere like a battery waiting to discharge. The result, lightning that doesn't just flash, but dances forked bolts splitting the sky up to 40 times a minute, illuminating the night with an eerie, strobing glow visible from 250 miles away. Scientists call it the world's most persistent thunderstorm, but locals know it as El Relámpago del Catatumbo, the Catatumbo Lightning. Some years, the storm takes brief hiatuses, like in 2010, when a drought silenced it for 6 weeks, sparking fears it might vanish forever. But like clockwork, it always returns, a reminder of nature's stubborn rhythms. Researchers now study this electrical powerhouse to unravel mysteries far beyond Venezuela. The storm's predictable patterns help test theories about atmospheric conductivity, while its methane-fueled discharges offer clues about how lightning might behave on other planets, where methane-rich atmospheres could spawn even wilder storms. Yet the Catatumbo Lightning isn't just a scientific curiosity, it's a cultural touchstone. Indigenous tribes once believed the flashes were spirits colliding in the heavens, while revolutionary Simon Bolivar credited the storm with helping his troops navigate during nighttime battles. Today, it's a UNESCO-protected natural wonder, a spectacle that draws storm chasers and photographers willing to brave the deafening thunder for a glimpse of nature's most dazzling light show. But perhaps the most humbling lesson lies in its fragility. Pollution, deforestation, and climate change threaten the delicate balance that sustains the storm. As wetlands shrink and temperatures rise, scientists wonder if this eternal lightning could one day flicker out. The Catatumbo Lightning isn't just a wonder to observe, it's a warning, a reminder that even the most enduring natural phenomena exist on a knife's edge. And in its electric glow, we see a truth as stark as the bolts themselves. Some mysteries aren't just meant to be solved, they're meant to be protected. On the windswept shores of New Zealand's Cocoa Beach, nature has scattered a collection of giant stone marbles, perfectly spherical boulders that look like the abandoned toys of some ancient giant. These are the Moeraki Boulders, and they're not just sitting there, they're on the move, weighing up to several tons each. These mysterious orbs appear to migrate across the sand, as if guided by unseen hands. But the truth behind their journey is a masterclass in how Earth's gentlest forces can reshape even the heaviest objects over time. The boulders began their story 60 million years ago, forming deep beneath the ocean floor. Minerals slowly gathered around tiny nuclei, perhaps a fossilized shell or a speck of organic matter, building layer upon layer like pearls in an oyster. Over millennia, these concretions grew into near-perfect spheres, their iron-rich cores creating cracks that filled with quartz and calcite, giving them their signature cracked egg appearance when eroded. For ages, they lay hidden, encased in soft mudstone cliffs. But as the sea gnawed at the coastline, the cliffs crumbled, releasing these geological treasures onto the beach like a cosmic game of marbles. What happens next is where the magic begins. Storms and tides, those tireless sculptors of the shoreline, take over. Waves nudge the boulders inch by inch, rolling them along the sand like driftwood. During particularly fierce storms, the ocean can heave these massive spheres several meters in a single night, leaving behind deep grooves in the sand as evidence of their travels. Some boulders even appear to cluster together, as if drawn by some invisible force, while others wander alone, pushed by currents or trapped in tidal pools. But the Moeraki Boulders aren't just a spectacle, they're a living lesson in coastal erosion. Most people think of erosion as a destructive force, chewing away at cliffs and swallowing beaches. Yet here, it's also a curator, revealing and repositioning natural artifacts that would otherwise remain locked in stone. The boulders act as time capsules, their movements mapping the beach's changing contours over decades. Scientists study their paths to predict how coastlines might evolve, offering clues about where cliffs will collapse next or how rising sea levels might redistribute sediment. What's truly remarkable, though, is how these boulders blur the line between geology and folklore. Maori legends speak of them as the petrified gourds and baskets of the ancestral canoe Araturu, washed ashore after a shipwreck. Early European settlers spun their own tales, speculating they were dinosaur eggs or even the remnants of a sunken city. Today, we know the science behind their formation, but that doesn't strip away their mystery. If anything, understanding how they roll only deepens the wonder, proof that even the most solid, unmovable-looking objects are part of Earth's endless dance. And perhaps that's the real lesson of the Moeraki Boulders. They remind us that nothing in nature is truly static. Given enough time, even stone can travel, shaped by the patient hands of wind and water. So the next time you see a boulder on a beach, pause and ask, how long has it been here and where might it go next? The answer might just surprise you. Death Valley's sailing stones might be the most famous rocks on the move, but they are far from alone. Venture to the arid plateaus of Argentina's Altos de Tailene, and you'll find their distant cousins' boulders carving serpentine trails across the desert floor. Or journey to South Africa's Richtersveld, where granite slabs slide like drunken chess pieces, leaving zigzagging scars in their wake. These global siblings share the same eerie mystery, rocks that wander without explanation. But here's the twist. Each location holds unique clues about how wind, soil, and climate conspire to make the impossible happen. Take Argentina's Tailene boulders. Unlike Death Valley's Playa, where ice does the heavy lifting, these rocks dance across a surface of loose volcanic ash. When fierce coastal winds whip through the Andes' rain shadow, they don't just nudge stones, they sculpt entire dune like waves of dust, creating a slippery carpet that lets boulders surf for dozens of feet in a single storm. The trails here aren't graceful curves but jagged dashes, like a pen skipping across paper, revealing moments when the wind gusted hard enough to overcome friction. Geologists studying these paths can practically reconstruct ancient wind speeds, using the rocks as natural anemometers frozen in time. Meanwhile, in South Africa's Richtersveld, the plot thickens. Here, the sliding stones aren't solitary travelers but part of a chaotic ensemble. Granite slabs, some as wide as cars, cluster together like a stalled convoy, their trails intersecting in tangled webs. The secret morning fog. Unlike Death Valley's ice or Argentina's wind-blown ash, this desert's moisture comes from coastal mist rolling in at dawn, dampening the soil just enough to reduce friction. As temperatures rise, the ground dries unevenly, creating miniature slip zones where rocks inch downhill over decades. The result is a slow-motion ballet, where boulders move in fits and starts, their paths recording centuries of microclimates in lines as deliberate as tree rings. What makes these global examples so invaluable isn't just their strangeness, it's the way they act as natural laboratories. By comparing trails across continents, scientists spot universal patterns. For instance, all three sites share one critical feature: perfectly flat terrain. Even a slight slope would send rocks tumbling haphazardly, erasing the delicate records left by wind or ice. But they also reveal stark differences. Argentina's wind-driven rocks move fastest, sometimes shifting visibly in a human lifetime, while Richtersveld's fog-assisted stones might take centuries to cross a football field. Death Valley's ice-rafted boulders, they're the Goldilocks of the group, rare enough to preserve their trails for study, but frequent enough to catch in the act. This global perspective doesn't just solve old puzzles, it uncovers new ones. In Chile's Atacama Desert, researchers recently found boulders with trails that spiral like snail shells, suggesting whirlwinds or rare rainfall events play a role. Even Mars has its own version. The red planet's dust devils leave tracks that resemble miniature sailing stone paths, hinting at similar processes playing out under alien skies. Every new site adds another piece to the puzzle, proving that Earth's quietest forces: a whisper of wind, a film of moisture, a sheet of ice thinner than a coin, can move mountains one pebble at a time. The real magic lies in what these stones teach us about patience. In a world obsessed with speed, they remind us that some of nature's most profound changes happen too slowly for human eyes to see. A boulder's trail might span generations, its journey beginning before Columbus set sail and ending long after our grandchildren are gone. Yet in those silent movements, the planet writes its diary, not in ink, but in stone and soil, waiting for us to learn its language. And as long as there are deserts, winds, and curious minds, the sailing stones will keep their secrets just within reach, inviting us to read between the lines. The waters of the Bahamas may glitter like sapphires under the Caribbean sun, but dive beneath the surface and you'll find portals to a world untouched by time or light. Among these submerged time capsules, one stands apart, the black hole of Andros. This isn't just another blue hole, it's a living relic of Earth's distant past, a toxic, oxygen-free abyss where the rules of life rewrite themselves. Plunge into its inky depths, and you're not just exploring a cave, you're stepping into a time machine, traveling back to an era when our planet's atmosphere was as alien as a distant moon. At first glance, the black hole seems unremarkable, a circular pool about 100 feet wide, its surface still as glass, but peer closer and the water reveals its secrets. A distinct layer of murky purple-black liquid hangs suspended like a floating curtain, separating the upper, oxygen-rich waters from the abyss below. This boundary, called a chemocline, is more than a visual oddity, it's a biological firewall. Below it, the water contains zero oxygen, saturated instead with hydrogen sulfide, a poison so potent it corrodes metal and suffocates most organisms in seconds. Yet somehow, life not only survives here, it thrives. The real marvel lies in the microbes that call this toxic zone home. These aren't your everyday bacteria, they're extremophiles, organisms that harness chemicals rather than sunlight for energy. Some breathe sulfur, converting hydrogen sulfide into survival fuel. Others feast on methane, their metabolisms so alien they're closer to life forms we'd expect to find near hydrothermal vents or on Jupiter's icy moon Europa. For scientists, these microbes are like biological time capsules, offering a glimpse into how Earth's earliest life forms might have endured our planet's oxygen-free infancy over 2.5 billion years ago. But the black hole's secrets don't stop there. Its stratified layers act like a living laboratory, each depth preserving different chapters of Earth's evolutionary story. Near the surface, cyanobacteria form thick mats, their photosynthesis slowly adding oxygen to the water, a miniature reenactment of the great oxygenation event that transformed our planet's atmosphere. Deeper down in the sulfur-rich darkness, conditions mirror those of the Proterozoic era, when the oceans were a toxic soup and life clung to existence in hostile niches. It's as if the whole has compressed billions of years of Earth's history into a single, vertical column, waiting for us to decode. What makes this place so invaluable isn't just its snapshot of the past, it's its lessons for the future. By studying how life persists in these extreme conditions, astrobiologists are rewriting the playbook on where to search for life beyond Earth. If microbes can flourish in the black hole's poison broth, why not in the subterranean oceans of Enceladus or the briny streaks of Mars? Even medical researchers are taking notes, examining how these organisms repair DNA damaged by toxic chemicals, insights that could lead to breakthroughs in cancer treatment or radiation resistance. Yet the black hole remains fiercely mysterious. Recent expeditions discovered jellyfish-like blobs of microbial mucus drifting through the depths, their purpose unknown. Other samples revealed viruses unlike any seen before, hinting at an entire shadow ecosystem lurking in the darkness. Every dive peels back another layer, but the abyss keeps its deepest secrets closed. And perhaps that's the real power of places like this. They remind us that Earth's most profound mysteries aren't always written in towering mountains or vast canyons. Sometimes they're hidden in quiet, murky pools where the water holds its breath and time moves differently. The black hole of Andros isn't just a geological oddity. It's a whisper from the primordial world, a reminder that life, in all its tenacity, will always find a way, even in the darkest corners. The Dead Sea is vanishing before our eyes, sinking faster than almost any body of water on Earth, its shoreline receding by over 3 feet every single year. This isn't some slow geological shift or natural cycle. It's a crisis engineered by human hands, and the consequences are written in the land itself. As the waters retreat, they leave behind a surreal and treacherous landscape, vast salt flats that crumble like stale bread, swallowing roads, buildings, and even entire beaches into gaping sinkholes. Over 7,000 of these voids pockmark the region now, some plunging 100 feet deep overnight, as if the Earth itself is collapsing under the weight of our mistakes. The root of this disaster lies in a simple but devastating equation. The Dead Sea, the saltiest body of water on the planet, has always relied on the Jordan River as its lifeline. But over the past century, nearly 90% of the river's flow has been diverted, siphoned off for irrigation, drinking water, and industry across Jordan, Israel, and Syria. With no fresh water to replenish it, the sea evaporates under the relentless desert sun, leaving behind thick crusts of salt where waves once lapped. Beneath these crusts, the real danger lurks. For millennia, the sea's weight pressed down on underground salt deposits, stabilizing them. Now, as the water vanishes, rainwater and underground springs seep into the exposed layers, dissolving the salt like sugar in tea. The ground above, suddenly hollowed out, collapses without warning. These sinkholes aren't just geological oddities, they're ticking time bombs. Some cluster in eerie sinkhole fields, where the Earth resembles Swiss cheese. Others open singly, their edges fracturing with hairline cracks before giving way. Local geologists have watched entire date palm orchards vanish into the abyss, the trees tilting at drunken angles before disappearing forever. Even the Dead Sea's famous resorts, once bustling with tourists floating in the buoyant waters, now stand abandoned, their access roads severed by pits that appeared overnight. The land here has become a minefield where every step could be your last. Yet amid the destruction, there's a grim fascination for science. The Dead Sea's sinkholes offer a rare chance to study how landscapes respond to extreme human intervention. By mapping their formation, researchers can predict similar collapses in other water-stressed regions, from California's Central Valley to the Aral Sea in Central Asia. The sinkholes also reveal unexpected silver linings. Some have filled with fresh water, creating accidental oases where new ecosystems thrive. Microorganisms adapted to extreme salinity bloom in these pools, offering clues about life's resilience in hostile environments and perhaps even on other planets. The Dead Sea's plight is a cautionary tale written in salt and sediment. It's proof that when we alter nature's balance, the planet often retaliates in ways we never anticipated. Sinkholes don't just swallow the land. They swallow our assumptions, forcing us to confront the fragility of the systems we take for granted. And as the sea continues to shrink, it leaves behind a question: how much longer until the damage is irreversible? The answer, like the sinkholes themselves, may already be hidden beneath the surface, waiting for the ground to give way. Imagine standing in the pitch-black night when suddenly, the sky flickers with ghostly orbs, floating spheres of blue or white light dancing along the horizon like will-o'-the-wisps. Moments later, the ground heaves violently beneath your feet. For centuries, survivors of major earthquakes reported these eerie illuminations, only to be dismissed as superstitious or hallucinating. But in August 2007, something extraordinary happened in Peru. As the coastal town of Pisco trembled under an 8.0 magnitude quake, security cameras captured undeniable proof. streaks of light bursting from the ground like reverse lightning, illuminating the chaos in an otherworldly glow. Science could no longer ignore the phenomenon. Earthquake lights were real, and their secrets might just revolutionize how we predict the planet's most violent movements. The key to this mystery lies in the rocks themselves. When tectonic plates grind against each other, the immense pressure doesn't just fracture stone, it electrifies it. Certain minerals, like quartz, have a peculiar property called piezoelectricity. Squeeze them hard enough, and they generate electrical charges. In fault zones under extreme stress, these charges can accumulate until they literally burst through the surface, ionizing the air and creating glowing plasma. Think of it like rubbing a balloon on your hair, except instead of static cling, you get a luminous precursor to disaster. Recent lab experiments have recreated this effect, subjecting rocks to crushing pressures and watching as sparks erupted along fault lines. Nature, it seems, has been sending us a distress signal all along. We just didn't know how to read it. What makes these lights so valuable isn't just their spectacle, it's their timing. Unlike most quake warnings, which arrive seconds before impact, earthquake lights can appear days or even weeks before the ground shakes. In L'Aquila, Italy, 2009, residents reported strange flashes in the sky weeks before a devastating 6.3 magnitude quake leveled the medieval city. Similar accounts followed the 2011 Tohoku quake in Japan and the 2016 Ecuador tremor. If we could reliably detect and interpret these luminous warnings, they might buy crucial time to evacuate cities or shut down vulnerable infrastructure. Yet the puzzle isn't fully solved. Not all major quakes produce lights, and their appearance varies wildly, from floating orbs to sheet-like auroras to jagged tendrils snaking upward. Some scientists theorize that atmospheric conditions like humidity or pollution act as a canvas, determining how the charges manifest. Others suspect underground water plays a role, with stressed rocks electrifying trapped aquifers, creating conductive pathways for the energy to escape. Even the composition of the crust matters. Lights appear more frequently in volcanic regions, where mineral-rich rocks like basalt dominate. It's as if Earth has multiple dialects for the same warning, and we're only beginning to learn the language. The implications stretch far beyond our planet. Similar glowing phenomena have been spotted on Mars's fault lines, hinting that electrostatic discharges might accompany quakes or Marsquakes there too. If so, future Martian colonists could use these lights as early warnings in a world without seismic networks. Even Venus, with its crushing atmosphere and volcanic fury, might whisper its tectonic secrets through similar bursts of light, detectable by orbiting probes. But here's the haunting truth. Earthquake lights remind us how much we still don't understand about the ground beneath us. For all our satellites and sensors, the Earth communicates in ways we're only starting to decipher. These luminous harbingers, once relegated to myth, now stand as beacons of a tantalizing possibility that one day we might not just predict quakes but see them coming. And in that glow, there's more than just science. There's a reminder that sometimes the oldest stories hold the newest truths. Deep in the heart of Arizona's Havasu Canyon, where the desert's scorching breath gives way to an improbable oasis, the hanging lakes of Havasupai defy every expectation. These are no ordinary pools. They're liquid jewels strung along the canyon like a necklace of turquoise and emerald, each one cradled in delicate travertine dams that seem too fragile to exist. But what makes these lakes truly mesmerizing isn't just their beauty. It's their ever-changing palette, shifting hues like a mood ring as minerals and sunlight conspire to rewrite their colors daily. The secret lies in the water's journey. Beneath the canyon, rainwater seeps through limestone bedrock, dissolving calcium carbonate as it travels. When this mineral-rich water bursts from springs at the canyon walls, it meets the open air, triggering a chemical ballet. Carbon dioxide escapes, causing the calcium carbonate to solidify into travertine, the same porous rock that forms the dams holding these lakes aloft. But here's where the magic happens. Suspended in this water are microscopic particles of copper, magnesium, and other minerals, each refracting light differently. When sunlight pierces the surface, it dances with these particles, transforming the lakes into living canvases. One day, a pool might glow electric blue from copper ions. The next, a bloom of algae could tint it jade green. Even the time of day plays a role. Dawn's golden light turns the water topaz, while midday sun unveils sapphire depths. Yet these lakes are more than a geological kaleidoscope. They're a barometer for our changing planet. Travertine forms only under precise conditions, a balance of water flow, temperature, and carbon dioxide levels. As climate shifts disrupt rainfall patterns in the southwest, scientists have noticed something alarming. The dams aren't growing as quickly as they once did. By measuring deposition rates in these pools, researchers can track how rising temperatures and dwindling groundwater affect carbonate systems worldwide. It's a warning written in stone, or rather, the lack of it. The hanging lakes also harbor a lesson in fragility. In 2008, a single hiker's misstep, a careless splash of sunscreen, triggered a bacterial bloom that clouded one pool for months. The incident revealed how exquisitely tuned these ecosystems are, where even trace contaminants can unravel centuries of mineral equilibrium. Today, the Havasu tribe, who have stewarded this land for generations, limit access to protect the lakes, recognizing them not just as wonders but as sacred teachers. What's most humbling is the scale of time at work here. The travertine dams grow roughly a quarter inch per year, meaning some of these pools have been cradled by stone for over 10,000 years. They've witnessed the entire span of human civilization, from the first footsteps of the Havasupi's ancestors to the modern era's climatic upheaval. And as they continue to shift and shimmer, they offer a quiet reminder. Earth's most breathtaking artistry often unfolds at the pace of a whisper, demanding our patience, our respect, and above all, our protection. From Death Valley's wandering stones to Antarctica's bleeding glaciers, these 30 mysteries shatter the illusion that our planet is just a static stage for life to play out. Each enigma we've explored, whether it's the Bermuda Triangle's methane explosions, the Great Unconformity's missing billion years, or the pufferfish's underwater crop circles, reveals Earth as a dynamic, ever-changing protagonist in its own epic. These aren't just quirks of nature, they're clues to a grander narrative, one where rocks breathe, oceans vanish, and continents waltz across the globe on timescales too vast for human minds to fully grasp. What unites these phenomena isn't just their strangeness, it's how they've humbled generations of scientists. Every time we've assumed we've figured Earth out, it throws us a curveball, a glacier that bleeds, a desert that sings, a lake that explodes without warning. These mysteries remind us that geology isn't a finished textbook but a living manuscript with new chapters being written in real time. And here's the thrilling part. The tools to decode them are more powerful than ever. LiDAR scans peer through jungle canopies to uncover lost rivers. AI models simulate ancient earthquakes, and satellites track continental shifts down to the millimeter. The next great discovery might not come from a lab-coated expert, but from a hiker with a smartphone or a farmer noticing odd cracks in the soil. That's the real invitation here. Whether you're marveling at the giant's Causeway's geometric perfection or puzzling over the Devil's Kettle's vanishing waterfall, you're participating in something bigger, a collective quest to understand our home. So which mystery gripped you the most? Did the sailing stone's icy ballet spark your curiosity? or did the boiling river's defiance of logic leave you awestruck? Drop your thoughts below. We're endlessly fascinated by which wonders resonate with fellow explorers. And if these stories left you hungry for more, you're in luck. Our deep dives into volcanic lightning, underwater caves, and other planetary puzzles are just a click away. The Earth's secrets are far from exhausted, and who knows? The next breakthrough might just have your name on it. After all, every great discovery begins with a simple question: